All right, pre-calculus people. So we're going to do a quick video today on the operations using complex and imaginary numbers. I went through the top part of these notes in class. It's not a super huge part of this. I'm not too worried about simplifying and stuff like that. The main part of this video I want to talk about is, again, just the operations, adding, subtracting, multiplying, dividing. Do remember our definition of I is the square root of -1. That's going to come in when we go down to multiplication. Okay. Also remember that a complex number is in this format a plus bi, where a is what we call the real part, and bi is called the imaginary part. So let's go ahead and jump into our basic operations. Adding, subtracting is the easy one. It's just combining like terms, which is the same thing you've been doing since your algebra days, even pre-algebra days. So like if we're doing that first one, so 6 minus 5i plus minus 4 plus I, we can do this in one step. I'm going to do it in two steps, just kind of show you what it would look like. So we can combine the 6 and the -4, and then just kind of combine the i's, -5i plus I, and then just kind of work out what that is, right? So 6 plus -4 is -2, -5i plus I is -4i, and that's it. And that is your final answer. Again, if you're more comfortable just kind of doing one step and kind of eyeballing it, that's totally okay too. How about the second one? And here's what I mean. So like, again, if we just combine the constants, 3 plus 9, and then combine the imaginary parts, and again, don't forget, just kind of be mindful of your arithmetic. So that's going to be 12 minus 5i. And that's it. And that's all you're going to do for your answer. Now, there is kind of a little catch here. The adding, there's nothing going on. When you're subtracting, you do have to remember you're distributing. So that minus sign is going to change the sign of both of those two things inside of that second set of parentheses. So in other words, what I'm going to do when I combine my terms this time, I'm going to do -3 minus 1, and then 2i plus 7i. Because remember, two negatives make a positive, and then we can just write our answer from there. Okay, so it'll be -4 plus 9i. Okay. Notice the first set of parentheses, that -3 plus 2i, those stay the same. There's nothing going on there, but we change the sign of those second two terms. So go ahead and pause the video real fast. See if you can do that last example by yourself, and then I'll run through the answer real fast. Okay, so again, the first one stays the same, so it's going to be 1 plus 9, again, minus a negative. That negative sign is getting distributed. And then we'll do -4i minus 6i. Again, that negative sign distributes through, and then just combine things. So we got 10 minus 10i. Okay? Adding, subtracting, combine like terms, watch your signs when you're combining those integers and combining the coefficients. Okay, so for multiplying, the main thing we need to know is one of the powers of I. And again, in class, I went through the higher powers, the I to the third, I to the fourth. I'm not going to do that in this video because the main thing we're going to be concerned about is I squared. But do notice, again, just using the definition, if I is the square root of -1, if I square both sides of that little equation, that means I squared is equal to -1, right? So this is the one that you definitely want to remember because it's going to come up and be used a lot in all of your multiplication and division questions for that matter. So on the first two examples, notice it's just going to be distributing. So again, just like we did kind of on the subtraction problems, 4i times -3, 4i times -2i. So that's going to be -12i minus 8i squared. But remember what we just said, if you see this I squared, this really means it's -8 times -1, which is equal to positive 8. So I'm going to write this final answer as 8 minus 12i. All I did was kind of rearrange it so it's in that complex number format, that a plus bi format. If you wrote that as negative 12i plus 8, totally okay. Okay? Let's do that next one. Again, distribute. 10i plus 6i squared. And again, remember that 6i squared is equal to negative 6. So I'm going to write that as negative 6 plus 10i. Now the next two, notice now we're getting in back into your Algebra 2 days, and even Algebra 1 days, when we had either FOIL or the box method to do this. So I'm going to do this first example both ways, and then I'll let you pause the video, do the last two, and then we'll check the answers. Okay, so if I'm doing the box method on that next example, I'm going to draw the box. 3 minus 5i and 2 plus 3i. And again, inside each box, you just multiply. So 2 times 3, 6. 2 times negative 5i, negative 10i. 3i times 3 is 9i, plus 9i. 3i times negative 5i is negative 15i squared. But again, just like those first two examples, at I squared is equal to negative 1, so that's really equal to positive 15. So I can combine like terms. Notice 6 plus 15 is 21. And then negative 10i plus 9i is just negative 1i, or just negative I. Okay? And if I do FOIL, it would look exactly the same way. You get the same numbers. You just do the first, outer, inner, last thing. So here's what that would look like. So again, we do first, 3 times 2. Last, 3 times 3i. Outer, I should say. So first, 3 times 2, 6. Outer, 3 times 3i, 9i. Inner, negative 5i times 2. And then the last, negative 5i plus 3i. But again, that all comes out to be the same thing. This is 6 minus I plus 15, and we combine the 6 and the 15 to get 21i. So go ahead and pause the video one more time and see if you can do those last two examples. Remember, on the last example, this is really saying 3 plus 5i times 3 plus 5i. So this is another FOIL and box method question. So on this example, I'm not going to do the box method. I'm just going to kind of work it out FOIL-wise and then just write the final answer. So, but you're going to get the same answers. So you get negative 12 plus 24i plus 2i minus 4i squared. When you simplify all that, remember this one is equal to positive 4. So you get negative 8 plus 26i. And then for the last one, we'll have 9 plus 15i plus another 15i plus 25i squared. But again, remember, this is equal to negative 25. So we'll have negative 16 plus 30i. Okay? So that's multiplying. Again, just remember, always simplify that I squared term. Okay? Last operation, division. Good news. There's no such thing as division. It's just multiplication. So this is going to turn into a multiplying problem, but we have to multiply by this thing called the conjugate. Now, the definition of a conjugate is right here. Given any complex number, a plus bi, the conjugate is just a minus bi. All that means, don't overthink that. It just means we're changing the sign of the imaginary part. So if you have 7 plus 3i, the conjugate would be 7 minus 3i. That's all there is to it. Okay? So if you want to kind of write these other conjugates down real fast, so what's the conjugate of negative 1 plus 6i? Negative 1 minus 6i. 3 minus 2i, conjugate, 3 plus 2i. Negative 4 minus 5i. Negative 4 plus 5i. You only change the sign of the imaginary part. That's it. So what we do to do division, even though it's not really division, we take 4 minus I, just take the problem, and we're going to multiply by the conjugate of the denominator. Conjugate of the denominator. Multiply both the top and the bottom by that. So the conjugate of the bottom is 2 minus 3i and 2 minus 3i. And you see, this just turns into two different multiplication problems, right? So let's go and do the top. So we have 8 minus 12i minus 2i plus 3i squared. Do the bottom, 4 minus 6i plus 6i minus 9i squared. We'll clean up the top. Remember, this is negative 3. So we have 5 minus 14i. But look what happens on the bottom. I got a negative 6i and a plus 6i. Those guys cancel out. And then I have this is equal to positive 9. So the bottom is just 13. Whenever you multiply by the conjugate, that will always happen. You will always just get a real number on the denominator. And that's what we want. Okay? So we're not really changing the problem any. We're just rewriting it so that there's not an imaginary in the denominator. So again, let's pause the video one more time. Let's see if you can do that same thing on the next example, and then we will wrap it up. So here's the problem. Again, we're going to multiply by the conjugate of the bottom. So 2 plus 5i. Over 2 plus 5i. And again, multiply 2 plus 5i plus 6i plus 15i squared. That's a weird looking plus sign. Let me do that again. Plus 15i squared over 4 minus 10i, I plus 10i, minus 10i, minus 25i squared. When you clean that up, you have negative 13 to minus 15. So we got negative 13 plus 11i over 29. Again, those middle I terms, those plus 10i, minus 10i, they will cancel out. And then the last example. In this case, my conjugate, you can still change the sign. So 2 plus 7i over 4i times negative 4i over negative 4i. This is just distributing on top, so it's negative 8i minus 28i squared over negative 16i squared. So again, cleaning that up, negative 28i squared is positive 28 minus 8i over 16. So those are the operations of complex numbers. If you need some more help with the assignment or understanding those operations, please come into tutoring. Until next time, stay safe.